The ocean receives more water than any other place on Earth. Every second, thousands of rivers, melting glaciers, underground currents, and storms pour billions of liters into it. Yet the ocean never overflows. It never rises endlessly. It never breaks the invisible balance that holds the planet together. The real question is not why the ocean stays where it is, but what force is powerful enough to stop it from drowning the world. To understand this, you need to follow a cycle older than life itself, a cycle that moves silently, without anyone noticing, repeating the same motion for billions of years. Imagine a raindrop falling into a river. It begins a journey that seems simple: the river flows into the sea, and the sea becomes the ocean. But the moment that drop reaches the coastline, something unexpected happens. Instead of staying, instead of adding volume and raising the waterline a little more, it vanishes. Not in a magical way, but in a process so familiar that people forget its true scale. The drop begins to rise back into the air, pulled upward by the heat of the sun. Evaporation is the invisible escape route for almost every drop of water in the world. What goes into the ocean eventually leaves it again, and the ocean remains trapped inside a cycle that never stops. The sun is the great engine behind this balance. Every ray of sunlight carries enough energy to lift trillions of water molecules back into the sky every single day. You can't see this happening, but the ocean is constantly breathing, exhaling vapor into the atmosphere and inhaling rivers back into itself. This enormous exchange is the reason sea levels stay stable for centuries at a time. For the ocean to overflow, the sun would need to stop shining or the atmosphere would need to disappear. And if either of those happened, the last thing we would worry about would be the height of the ocean. But the sun is not the only guardian maintaining this fragile equilibrium. Gravity plays its own role, creating boundaries no water can cross. The ocean is held inside giant basins carved into Earth's crust. These basins are massive depressions deep enough to hold all the water on the planet with room to spare. If Earth were a perfectly smooth sphere, water would cover the entire surface in a layer more than 2.5 kilometers deep. But Earth is not smooth. Its crust is uneven, shaped by tectonic forces that created trenches, ridges, and continental shelves. These features act as natural containers, and the water can rise only until it fills the available space, never more. While rivers pour water into the ocean, something even stronger pulls it back out: the atmosphere. The warmer the air, the faster evaporation happens. In tropical regions, sunlight removes more water from the surface than all the rivers combined. Most of this vapor travels across the planet before falling again as rain. Sometimes it returns to the ocean, sometimes it feeds forests, sometimes it becomes snow in the poles. But eventually, through melting, runoff, or groundwater, it always ends up back in the sea. The ocean never fills because it is constantly losing water at the same speed it gains it. And while we're talking about speed, here's a detail almost no one knows: if evaporation stopped for a single day, even with all rivers running at full force, the ocean level would rise only a fraction of a millimeter. It would take hundreds of years without evaporation for the ocean to rise enough to cause catastrophic global flooding. The balance is too strong, too well adjusted by nature, and too deeply tied to the laws of physics to be easily broken. Before we continue this journey, imagine this: right now, at this exact moment, the ocean is evaporating enough water to form storms on the other side of the planet. This vapor will fall as rain in places that may never see the sea. And yet, everything eventually returns to the ocean. If you want to keep learning the true logic hidden behind our planet, don't forget to subscribe to Curious Horizon. Every week we reveal another secret of the natural world that few people truly understand. Now, let's go deeper. The ocean's stability depends not only on sunlight and gravity but also on geology. Beneath the water lies a world in constant transformation. Tectonic plates shift, collide, and separate. Sometimes the ocean floor sinks slowly, creating more space for water. Other times, volcanic activity builds underwater mountains, shrinking the basins. But these changes happen over millions of years, too slow to upset the water cycle. Even when a massive earthquake lifts or lowers a coastline by several meters, the global ocean barely notices. Its volume is too vast, its basins too deep. Still, humanity is powerful enough to disturb this balance. Rising greenhouse gases warm the atmosphere, accelerating evaporation but also melting glaciers and ice sheets at a speed the planet has never experienced before. This extra water flows into the ocean faster than it can leave as vapor. That's why sea levels today are rising, not because the ocean is filling on its own, but because we are breaking the ancient rhythm of the water cycle. And here is the most surprising part: if every glacier melted, the ocean would rise around 70 meters. Cities would vanish. Continents would shrink. Coastlines would be redrawn. But even then, the ocean would not overflow. It would simply fill more of the basins carved into the crust. It would remain under the same gravitational limits. It would still stay inside Earth's natural boundaries. That is how enormous the ocean basins truly are. When you stand on the shore and watch the waves crash, you are seeing only the surface of a system so precise, so ancient, and so vast that no single river, no single storm, and no single meltwater flow can change it. The ocean looks alive, unpredictable, restless. But deep down, it obeys laws that never change. The laws of energy, gravity, and motion hold it in place, creating a world where water is always moving but never escaping. In the end, the ocean never fills because it never stops flowing. Water falls from the sky, enters rivers, reaches the sea, evaporates, freezes, melts, and returns again. A cycle without beginning or end. A pulse that beats beneath every cloud, every storm, and every wave. The next time you look at the sea, remember, it isn't overflowing because it is breathing. Quietly. Constantly. Endlessly.